Yeah, for sure. So with Alerty, we are looking at a few things, right? So it's a very data intensive applications. So we have these requirements of we need to ingest and store and query a tons of data. So there's a lot of consideration into how we can integrate a data backend into the system. And in terms of application deployment, we know from the very beginning that we wanted to be more event driven and microservice based. So there's a lot of consideration on how we can enable the team to deploy and operate dozens of services very easily at the same time. And another really critical component for us is to have staging environment and production environment running side by side. So from our previous experience building applications, staging environment is very critical to make sure that the changes we're putting out can passes all the internal checks. So we don't want to have a code that go directly from a pull request to production, because that usually don't end up working too well. It might be fine for the first few weeks, but then after that, you always have unpredicted issues. And the staging environment really solved that problem for us. Yeah, so when we started building Alerty, we had a lot of learning from previous companies. So the requirement for us is we wanted to have staging environment. We want to have branch deployment for the front ends for preview, and we want to have microservice architecture, and we also want to have a data-intensive backend. So at its core, Alerty has a microservice-based backend. So we're running our data ingestion service that process and ingest all the data we're collecting. So from there, we have a few data backends. So we're using ClickHouse as the primary data warehouse to store most of the text-based data. We're using Prometheus to store all the metrics and other time series data. It's all stored in Prometheus. AI definitely comes with a few really unique challenges. The number one challenge with AI application is the support for a streaming request. So one of the common use cases in AI is when the user type a prompt into the chat, they expect to see the result immediately and in a streaming fashion. And this is a really tough technical barrier for a lot of platforms where they do not natively support this kind of streaming request. A lot of the infrastructure layer was designed with traditional HTTP requests or GraphQL requests in mind. It is a technical challenge for us to make sure our infrastructure layer can nicely support the streaming response. And we were able to achieve it with our custom built Go backend that has a streaming HTTP response. So on the front end side, we have a Next.js application. Zeet manages the CI/CD process. It manages the preview environment, staging environment, and production environment. So when our developer makes the pull request or create a branch on GitHub, Zeet will automatically deploy that change and give a preview URL for us to look at. And that's all seamlessly integrated and does not require any special configuration or YAML file. Our front-end team are able to create that experience just from a few button click on the Zeet platform. So that's been really important for our front-end experience, having the capability to manage all the environment easily. On the infrastructure side, Zeet has been a really great experience because we're using a lot of AWS managed service. For example, we're using AWS managed Kafka, AWS managed Prometheus, and some other data services. And all these services essentially runs alongside our Zeet deployment. And our application can seamlessly integrate with these AWS managed infrastructure while using Zeet at the same time. Yeah, we're definitely looking a lot into the multi-cluster deployment capability. Right now, our multi-regional deployments are orchestrated through Terraform. That's because they're all self-contained monitoring probe. But we also imagine that our core application, including our backend containers and workers, could potentially run multi-region as well. And if we want to achieve that, then we think that using these multi-cluster deployment is going to be a critical step into enabling that kind of deployment to happen. In a lot of other deployment tools that we used in the past, including GitHub Actions and other platform as services, they never really have good integration with the cloud infrastructure itself. From my experience using GitHub Actions, as a developer, I don't really get any visibility into what resources deployed. I have a really nice understanding of how the deployment workflow works and the configuration that goes into it. But after the deployment process is finished, I'm kind of put into blind from there. And Zeet really does it in a different way where even after the deployment process, it still provides me with the operational dashboard and a control plane that can follow up the deployment and understand, is it successfully deployed? Is it in health checking? Is it having issues? I can follow through that very easily. And compared to other platform as service, the level of integration Zeet has with cloud provider is really useful to us. With our data intensive application, we had to use a lot of the managed data service. For example, Kafka, ClickHouse, Prometheus, all these data service, it's only possible to really use them in a public cloud environment. And for a lot of the platform provider that I used in the past, it's really difficult to integrate the data service that's deployed on public cloud and with the application. With Zeet, I have this native integration that let me not only access these resources, but also access in a secure way through IAM access policies. And that's been a really game changer for us in terms of integrating our backend with this data infrastructure managed by the cloud provider.